All right, so got all this stuff up over here. This is going to be one of our error analysis problems that I will go over. You might see that it's similar to the stuff we went over on in class. I just added another person now. So let's go through everyone's thought process and see where they may have made mistakes. To start, you should focus on the triangle instead of what everyone did. Get your information started properly so that you can now compare. We have 59 over here. This is our reference angle. So that means this side that's not labeled will be our adjacent side. This side that is 5, we'll call that our opposite side. And then x is the hypotenuse. This is our reference angle, and let's start. Let's go through Joey's. So Joey sets up his equation at cosine of 59 is equal to x over 5. So as a reminder, cosine of some reference angle we'll call theta is always going to be equal to the adjacent side over the hypotenuse. So that's our ratio that we're working with. Now, if you might notice, our adjacent side, there's nothing over there. So there's nothing we can put on our adjacent side. So there's already an issue because x is our hypotenuse and 5 is the opposite side. But that's not our setup for whenever we use cosine. So already we can see that Joey made a mistake with his setup. So Joey has to be wrong. Put a little x over here next to this name. Alright, now let's look at Monica's. She also did cosine of 59. Right? So let's assume that you didn't look at Joey's and you went straight to Monica's. Monica's setup has cosine of 59 is equal to 5 over x. So as we know, cosine of some angle is going to be equal to the adjacent side over the hypotenuse. But Monica over here, she has 5, which is the opposite side, over the hypotenuse. So now we have kind of a usable ratio, but she used the incorrect trig ratio. So she shouldn't have used cosine in this case. So she made a mistake over here as well. Her setup kind of works because now she's using some sides. It's in a ratio position that we're familiar with, but she used a trig function that doesn't go with it. So Monica also is incorrect when setting up. Now let's look at Ross. Maybe he's wrong too. Let's go through the steps. He used sine. So as a reminder, sine of some angle is going to be equal to the opposite side over the hypotenuse. So let's look at the values he used. He used 59, which is correct. And then he has 5, which is the opposite side over the hypotenuse. So his ratio setup is correct. But let's keep going through his work to make sure every step that he did was also correct. So he has an x at the bottom, so we want to get that x out from the bottom of the fraction. We multiply both sides by x. So on the right side, the x on the top and the x on the bottom, they even out. That turns into just 1 times 5. And on this side, we have x times sine of 59. All right, so we do, that's good over here. That's correct, and I'll put check mark over there to show that's also correct. Then we've got this next step. he divides the sine of 59 from both sides to get x by itself. Remember, sine of 59 is just some number, so we can always do a number divided by itself. Will always work out in this case. It'll cancel out, but even out. So we did it on one side, and we divide on the other side as well. That step's correct. And then his final setup is x is equal to 5 over sine of 59. Let's plug that into our calculator and see what that comes out to be. Okay, we got x is equal to 5.833. We'll round that up to 5.8. Right. So I'll move away so you guys can take a look at the work. So as a reminder, when we're given an error analysis problem like this, think about, don't look at what everyone did first. First, let's set up our triangle. Let's label everything, know what we're using, know what we're not using. If in any of these cases there was another angle that was in play, you could also verify that angle matches up here. So let's say we wanted to find this one. 180 minus 59 minus 90. That's going to give us our angle at the top. That gives us one at the top over here. So if any of the problems use a different angle, we want to verify that angle is correct. So we solve for that missing angle just now, and we label all of our sides, so that when we start going into checking everyone's calculations, we can see who is correct and who is wrong.